Calculus kids, this is Dr. Callahan with Week 10 Wednesday. How are you guys doing? Go ahead and pause the video and answer the following questions for your warm-up log for Week 10 Wednesday. All right, let's go ahead and create the assignment for today. So you should have today as Week 10 Wednesday, and our topic of discussion is going to be on your assessment from AP Collegebd, and it is going to be on differential equation word problems. And your instruction today is to go ahead and make sure you guys watch the video in its entirety. Check in with me by 9:29, which is the second period for Wednesday. And then if you have any assignments to upload, make sure you do so by 3 p.m. Wednesday afternoon. Okay, let's go ahead and go back to this. All right, let's go ahead and take a look at your warm-up log questions. So this one is on a projection model with animals, and the formula that you guys use is this one right here. And so looking at this, it says 10 grizzly bears were introduced to a national park 10 years ago. There are 23 bears at the park in present time, okay? So the park can support up to a maximum of 100 bears. And assuming the logistic model, when will the bear population reach in 50 bears, 75 bears, 100 bears? So your job here is to figure out the time in years, okay? So I always told you guys to identify at least 2 different points, and then the third point, which is the point that you're trying to find. So here, I always like to use X, Y. So T is going to be in time, in years. Y is going to be your number of bears. And so you started off 10 years ago, so the time was 0, and there were 10 years ago, there were 10 grizzly bears, so 0, 10. Present day, this is 10 years later, and there are 23 bears at the park, and they're asking you, what time will there be 50 bears? At what time will there be 75 bears? At what time will there be 100 bears? Because the maximum you can get is 100. And maybe if you're opening like some kind of a, wildlife refugee, park or something, and the maximum number of bears is 100, you probably want to figure out what is the expansion years that you can sustain 100 bears at this refuge before you have to purchase more land, or maybe expand the refuge a little bit more so that way you can accommodate to all the bears that will be there. All right, so then here's your model. Now your model here is P, which is the number of bears. T is right here, which is time in years. And then M. Now your M is going to be the maximum of what you can have, which is 100. So if you're going to become an ecologist, in Nevada, we have like the battle-born sheep, we have a lot of cows herding, we have deers and elk and stuff up. I'm sorry, we don't have elk. We have deers, and I don't hunt, so I have no idea what else we have. That's wildlife. Maybe, I don't know, like ducks or birds or something, the sage grouse. So if you want to keep track of animals in that sense, this is the model that you will be using. So let's go ahead and do this. I see that my first one is going to be a 0 for the X value. So you're going to use the first one to go ahead and find C. Well, in this case, C is now A. I mean, I don't understand why they keep changing the letters, with this, but you're going to be using this to find C. So let's go ahead and do this. So your original equation is P is equal to 100, 1 plus AE to the negative KT. So then your P is 10 equals 100 over 1 plus AE to the negative, well, K times 0 is just 0. So this entire thing is just going to be 1. So really, you're just left with A. So I'm just going to erase this entire thing because it's going to make it more messy. All right, let's solve for it. Let's cross multiply. So I'm going to have a 10 times 1 plus a is equal to 100. Divided by 10 on both sides, 1 plus a equals 10, because 100 divided by 10 is 10. And then you're going to subtract the 1. So a, in this case, is equal to 9. So you have your first piece of your information. Now that I have that, I'm going to rewrite my equation. And this really is my first rewrite. It's going to give me a p is equal to 100 over 1 plus 9 e to the negative kt. Okay, so then now we're going to go ahead and use the second point right here to go ahead and find k. So let's do that. I'm going to have 23 is equal to 100 over 1 plus 9e to the negative k times 10. And then looking at this here, I'm going to go ahead and cross multiply this. When I do that, I will have a 23 times 1 plus 9e to the negative 10k. And notice how I'm not distributing this because I want to get rid of the 23. I don't necessarily want to distribute it because my goal here is to go ahead and find k. If I distribute it, it's going to make the equation even bigger. I just want to get rid of the 23 by dividing it. Equal to 100 divided by the 23 on both sides, 1 plus 9e to the negative 10k equals 100 divided by 23 is going to give you a 4.34. Okay, subtract 1 on both sides, 9e to the negative 10k equals 3.34. Divided by 9 on both sides, e to the negative k equals 3.34. Divided by 9 is 0.371981. Okay, now you guys know at this point, you're going to do the ln of both sides, and then you're going to divide it by negative 10. So k is equal to ln of 0.372, just round it, divided by negative 10. And if you go ahead and put this into your calculator, you will have a k is equal to a 0.099, which is k. All right, so then with that new information, I'm going to go ahead and rewrite my k one more time. So this will be my second rewrite. So I'll have p is equal to 100 over 1 plus 9e to the negative 0.099t. Okay, this officially is your equation. And with this equation, you can plug in any value for t, and you will go ahead and get the value for how many bears you have. But the question is not asking me to find the number of bears, or it's asking me if I have 50 bears, how long would it take to reach that population of 50? So if I were to do that, I could either do this, with my hand and algebraically, which will just give me, like, let's say 50 is the bear equals 100 over 1 plus 9e to the negative 0.00 or 0.99t. You can go ahead and cross multiply. And after a while, you could kind of notice this is going to become like a repeat of everything else. 100 divided by 50 is going to give me a 2. Subtract the 1 on both sides. I'm going to get 2 minus 1, which is a 1. Divided by the 9, you're going to eventually have ln 1 divided by 9. So then you're going to ln both sides. So you're going to end up with negative 0.099t equals the ln 1 over 9. And then lastly, you're going to go ahead and divide it by the negative 0.099. So then t equals ln 1 over 9 divided by the negative 0.099, which is going to give you a t value of 23 years, I believe. You could go ahead and graph that model as well, which is what I'm going to show you guys to do here, since it's asking you for 3 different time frames. So if I were to go ahead and graph this, my model will look something like this on your calculator. So then if I were to look at this from the perspective of 50 bears, it looks like it's about, I don't know, 23 years or 22 years. If I want 75 bears, it looks like it's about maybe 33 years. And then if I want 100 bears, it's looking at 75 years. So given the fact that right now is year 10 in the present sense, you have 65 more years before the sanctuary, the wildlife sanctuary, is going to be at its maximum with 100 bears. So you have 65 years to go ahead and figure out what it is that you want to do. So you have 65 years from current day until the sanctuary is maximized with 100 grizzly bears. Okay, so that's something that you can go ahead and write down and say. All right, you guys, the next thing I want to talk about was the 2 questions that I had from yesterday in class. I felt like I didn't do a very good job explaining this, and I hate to just go ahead and let it go and move on. So I want to go ahead and redo this one, and that way provide you guys with a better understanding of this. Okay, so it says, suppose experimental population of fruit flies increase according to increase. So if it's increased, you know your K value is positive. According to the law of exponential growth, there were 100 flies after the 2nd day of experiment and 300 days after the 4th day. So if this continues, approximately how many flies were in the original population? So you guys have points, right? And the first one is going to be time, and that's going to be in days. And then next one, your Y value, is going to be the number of flies, okay? So it's given to you that on day 2, you had 100 fruit flies. Day 4, you have 300. And so it's asking you, how many fruit flies did you start off with, you know, if it was day 0? So obviously trying to make this with common sense, you know it's going to be less than 100. And so with that said, let's go ahead and set this thing up. So your initial equation is going to be f of t is equals f of 0 e to the k t, okay? So then with this one, you're going to have to use these 2 equations, set them up equally, so you're going to match them, and then set them up equal to each other. So if I set up the first one at f of 2, then I have f of 0 equals k times 2, and that equals 100. Then if I set up f of 4, that's as f of 0 e to the k times 4, which is equal to 300. Now, as I'm looking at these 2 equations, what do they both share? And I see that they both share f of 0. So if I get f of 0 for both of them, then I know that f of 0, whatever that's equal to, I can set it equal to f of 0. Okay, so essentially what I'm trying to say is if I can get f of 0 equals a, and then I can say f of 0 equals b, then I can say a equals b, right? So then if I solve for f of 0 here, I will have to divide it by e to the 2k on both sides. So I can do that. But then if I divide it, I need to move it up to the numerator. So it'll just be 100 e to the negative k 2 times 2, or negative 2k. Similarly here, if I were to divide by the e to the 4k on both sides, this part will cancel, and I have f of 0 is equal to 300 e to the negative 4k. And now that I have these two equal to each other, I can now set these two equations to equal each other. So then I have 100 e to the negative 2k equals 300 e to the negative 4k. Well, my goal here is to solve for k, so let's get rid of the 100. So I have e to the negative 2k equals 300 divided by 100 is 3e to the negative 4k. Next, let's go ahead and combine the e's by moving e to the negative 4k to the left. If I move it over to the left, it becomes a positive 4k. Positive 4k minus 2k is e to the positive 2k equals 3. Now let's go ahead and do the ln of both sides. So then I have ln e, which cancels, and I have 2k equals ln 3 divided by 2 on both sides. K equals ln 3 divided by 2, which I don't like having in a fraction. So in a decimal, it's 0.5493. Given the fact that k is equal to a positive number, you know that over time, your fruit flies are increasing. And they are because they're going from like 100 to 300. Okay, so now that I have that, I'm going to go ahead and rewrite my equation. So when I rewrite my equation, I'm going to have f of t equals f of 0 e to the k, and your k is 0.5, just round it, 0.55 t. So I want to know how many fruit flies I have if t is at 0. So then what I'm going to do is, looking at this here, I know that my original fruit flies is going to be at 100 because I know that f of 2 is equal to f of 0. Sorry, I don't know why it's doing that. F of 0 e to the 2k, which is equal to 100. So then if I go ahead and do f of 0, then I will have f of 0. Oops. Erase that. Oops. Go back. Come on. Okay. F of 0, e to the 0, which is 1, equals 100. So f of 0 times e is just f of 0, which is 100. So then I'm going to replace this f of 0 with 100, okay? Now that I have that part complete, I could do f of x equals 0, which is going to equal to 100 e 0.55 times 0, which is just going to give me, oh, hold on a second. To the negative 2 times 0.55, which is then going to plug it in and to give you 33 flies, and that's the number of flies that you started off with. Okay, so let's go ahead and take a look at example 3. I'm going to try to see if, no, that's good. I'm going to change those colors a little bit because they're a little bit too bright for me. Let's change that to maybe a darker green. Oh, that's good. Okay, so let's go ahead and take a look at this question here. All right, so here it's saying 4 months after it stopped advertising, a manufacturing company noticed that its sales have dropped. So if something's dropping and decreasing, the K is going to be negative. So 4 months after it stopped advertising, it noticed the sales have dropped from 100,000 units to 80,000 units, okay? So here I'm going to use time in months, and this is the manufacturer units, okay? So 4 months after it stopped advertising, so when the time was 0, it originally started off with 100,000 units. 4 months later after it stopped advertising, probably because people stopped purchasing it because they don't see the advertisement, it went down to 80,000. And then it says if the sales continue with the pattern decline, what would it be in another 2 months? So that 2 months is saying 4 months plus the 2 months. So in 6 months, how many units are you expected to sell? So these are our 3 points, or the 2 points. And then the equation that you have is f of t is equal to, starting off at 100,000, e to the k t. All right, let's go ahead and start off with the first point. So I'm going to go ahead and say that if I were to go ahead and plug in the first point right here, I'm going to have f of 0 is equal to 100,000. E to the k times 0 is equal to 100,000. Okay, this entire thing becomes 1. So then what do I have? Then I just essentially have 100,000 equals 100,000. So we'll just start right there. Then I do the second point, which is f of 4, and that's going to give me 100,000 e to the k times 4 equals 80,000. So first equation doesn't do anything for me, but the second equation, I can go ahead and work with this. My goal here is to go ahead and solve for k. So then looking at this, I'm going to go ahead and just divide by 100,000 on both sides. So my first step is to go ahead and divide by 100,000. So then I'm left with the e to the 4k equals 0.8. Next, I want to go ahead and do ln on both sides. So I have 4k equals ln 0.8. Next, I want to go ahead and divide it by the 4 and solve for k. So then my k equals ln 0.8 divided by 4. And if I go ahead and divide that, k is equal to a negative 0.0558. Okay, so now I'm going to go ahead and go back to the original equation. my original equation is f of t, which is right here. Original equation is equal to 100,000 e to the k, so I'm going to replace that, t. Okay, now that I have this, my goal here is to figure out when the year is 6, how many units do I still have? So I'm going to do f of 6 is equal to 100,000 e to the negative 0.0558 times 6. So you want to grab your calculator, go ahead and plug that in, and you'll find out that f of 6 is equal to 71,500 units. And that is your answer. So your fifth step is your TI 84. All right, you guys, that pretty much showcased how you go about finding these 3 questions. I know the first 2, I didn't do a very good job explaining. I'm so sorry. And then on top of this, you also have the Newton's law of cooling. So to test out your skills, and actually your assessment on AP College Board is not as difficult as these questions here. So that's good. It is basically 10 questions, multiple choice on AP College Board. It looks like this right here. It just says week 10 Wednesday. And if you have any difficulty or if you need to have access to a hard copy, I will be more than happy to go ahead and attach this onto the assignment here as well. So I'm going to go back over here. And I'm just going to go ahead and attach it. Upload from my computer. Week 10. Open. Upload file. Send. And I'm trying to open it, but it's not opening for some reason. I'm not sure if it's just my computer. Hopefully it's not just mine. Okay, here we go. And there you go. And you have access to the questions itself as well. Anything that has a little calculator means that you will need a calculator access, probably most likely for the, for E and whatnot. But anyways, you guys, I hope you have a wonderful week. And as always, stay safe and healthy and try to take care of one another and be kind to one another. All right, I'll see you guys next time. Bye.